All right, so today is the last day of pre-algebra, and we're going to be going over decimals and fractions and ratios and proportions.
Today's agenda. So we're first going to review the homework, and then we're going to go through fractions, like arithmetic with fractions, like how to add fractions, subtract fractions, multiply, and then we're going to go through decimals. Uh, and more like specifically, we're going to be going into like rounding and how to convert repeating decimals. And then we're going to go through ratios and proportions. Then we have practice problems and a fun activity planned at the end.
So first we're going to go over our homework from yesterday, and please put your answer in the chat as we go through the problems. So our first question was, find the mode of the following data set. And once we get a few answers, we'll reveal the answer. Okay, so I'm seeing a lot of 1,203s, and that was the correct answer. Good job. So that's because the mode is the most frequent number in the data set, and we can see that 1,203 shows up more than any other number, meaning that it is the unique mode for this data set.
All right, problem 2. At Todd's school, there are 12 classrooms and an average of 3 board students per classroom. Tiffany's school has 8 classrooms, and the mean number of board students per classroom there is 8. And you should find the average number of board students per classroom in both schools combined. So go ahead, put your answers in the chat. All right, good. The answer is 5 students. And so to find what we need to find, first we have to calculate the total number of board students between both schools and the total number of classrooms. So if we multiply, so in Todd's school, there are 12 classrooms and 3 board students per classroom. So that's, that would be 36 board students. Tiffany would be 8 times 8, 64. And you add those together to get 100 total board students. Then you also add the number of classrooms. 12 plus 8 equals 20. And then you divide the total number of students by the total number of classrooms, which gets you 5 board students per classroom on average.
Okay, so problem number 3. The third quartile is how many times greater than the difference between the range and the interquartile range? Okay. Yeah, so mostly everybody's already saying that the answer is 2, and this is correct. Because the third quartile here is going to be 16, and the range is 21 minus 3, and that's 18. And the interquartile range is 16 minus 6, and that's 10. The difference between the range and interquartile range is 18 minus 10, which is 8, and 16 is 2 times greater than 8.
So number 4 was, what is the median of the first 2,099 positive integers?
Oops, sorry about that.
Okay, well, everyone is putting 1,050, so good job. And so if we tried to cross out numbers from each side until we were left with just one, which is a good method for like a smaller data set, it would take a very long time for this one. So instead, we can find the number 1 lower than the middle number, so 1 lower than the median. And we know that in this case, there is a middle number since the length of the list is odd. And then we can add 1 to that to get our median. So to do this, we subtract 1 from 2,099, and then we divide by 2. So that gives us 1,049, and then we can add 1 to get the middle number. Yeah, keep clicking a little. Okay, so if that didn't make too much sense, we're gonna look at a little more simplified version. So if we look at to find the median of the first 5 positive integers, we can see the numbers on the left. So we can see that there are three groups of numbers, the ones to the left of the median, so the red ones, and then the median, the blue one, and then the ones to the right of the median, so the black ones. And if we find the value of the rightmost red number, so the number that's one lower than the median, we can add one to get the median. So just like last time in the actual question, we can subtract 1 from the number they give us in the problem, so 5 minus 1, and then we divide by 2. So that gives us 2, and then if we add 1, we get 3 as our median.
Okay, problem 5. A dataset with 8 consecutive integers has a mean of 17. Find the range of the dataset. Yep, the answer here is 14. Okay, so one method for doing this is instead of actually going and finding the values of the 8 integers, you can use some algebra and you can set the first even integer to a. And the second one is a plus 2, the third one is a plus 4, the fourth one is a plus 6, and then you just keep going. And you know that the 8th integer in terms of a would be a plus 14. And then so this gives us that gives us this equation to find the range of the data set, which is the largest number minus the smallest number. And then that tells us that the range is 14. For this problem, since the numbers are kind of small, you can actually do it where you just find all the numbers also pretty easily. But this algebra way is better like in the long run. So it's good to know.
Okay, so we're going to go through like fractions relatively quickly. And so first of all, what do you guys know about fractions? Can someone give me like a definition in chat maybe? Okay, a part of a whole. All right, yeah, a fraction is like 1/2 is a common example of a fraction. A way of division. Okay. Yeah, a fraction is a part of a whole, is what most people are saying, and that it's like a part of a number. And this is this is like yeah, this is true. It's called a part of a whole. And yeah, it's just a way of representing a ratio between two numbers. So say for example we have the fraction a over b, where a is a number and b is a non-zero number, where a non-zero number means that b is not going to be equal to 0, because remember, you can't divide by 0. So the fraction a over b is going to be equal to a divided by b. So okay, what do you guys call the top part of a fraction? Not the numerator, but the numerator. It's called the numerator, yeah. Okay, what about the bottom part of a fraction? What do you guys call that? Yeah, it's going to be called the denominator. And so the number at the top of the fraction shows how many parts we have, and the number at the bottom shows how many equal parts the whole is divided into. So what do you guys think an improper fraction is? Yeah, an improper fraction is when the numerator is bigger than the denominator, and usually you can Jivitish, okay, that's 11 halves, right? Okay. Yeah, so where the numerator is greater than the denominator, and usually you can write improper fractions as mixed numbers. So for example, like 15/4 can be written as 3 3/4. So now we're just going to go through arithmetic with fractions. And I think that this is going to be mostly review for all of you guys. So can someone explain or write how to add fractions? So to add, or actually it's fine, I can go through it. To add fractions, yeah, you need to get a common denominator. You can only add or subtract fractions with the same denominator. So you need to find the common denominator and then you just add the numerators. Yeah. So that's what you do. So to find the common denominator, you guys can actually use what we learned a few classes ago where we used LCM, right? So like the LCM of 3 and 5 would be so the LCM of 3 and 5 would be 15, and then we can kind of expand the fractions and then add them together, right? And to multiply fractions, yeah, don't get confused with cross multiplication. I think Khan Academy has a really good video on it, but and to multiply fractions, it's pretty simple. You just multiply the numerators together and denominators together to form a new fraction, and then you need to simplify. You need to reduce it to the most terms. So like for example, 5 over 21 times 3 over 4. This is going to be equal to 15 over 84, and that's 5 over 28. Okay. And then division. So so division is kind of tricky, but not really. So you just need to find the reciprocal of the fraction that you're dividing by. So that would be like the second number. So you multiply the first fraction by the reciprocal of the second number that you're dividing by. And then you can just simplify afterwards. So 4/5 divided by 3/4 would just be 4/5 times 4/3, and that's going to be equal to 16/15. Are there any questions about any of these four operations? No, don't be afraid to ask questions. We can go through it, for example, because I think I went over addition pretty quickly. That's usually what people have the most trouble on. If you guys don't have questions, then that's fine.
Okay, so what is a decimal? If you guys want to like put in the chat again, similar to what we did for fractions, what you know about decimals. So like what is it or what do you know about it? Okay, so a decimal is a fraction in a different form. That's true. Okay, so 1.05 is a good example of a decimal. So a decimal is part of a whole. Okay, so yeah, so decimals are similar to normal numbers, and the digit represents a certain number based on its place value. So if you look at the diagram on the screen, just like the one on the very left, so like the 17, the one on the very left, represents a 10 instead of just a 1. The 5, the third digit, represents 0.5 or 5 over 10 instead of 5. So it's basically just like how you would read a normal number, except it gets smaller so as you go to the right, it gets smaller and smaller. So we're quickly gonna go over arithmetic with decimals also. So for addition and subtraction, it's basically the same as normal addition and subtraction, but you just have to make sure to line up the decimal points. So you have to line up the place values so that you don't add like a value in the like tens digit with the hundreds, something like that. So multiplication is similar to normal multiplication, but one thing is, so at the end, you have to count how many numbers are after the decimal point in the numbers you are multiplying, and then the answer should have that many numbers after its decimal point. So what that means is, So first, let's say I just multiplied these two numbers, 0.3 and then 1.22. Then at the end, I would just get this number 0.366. But at the end, I have to count how many numbers are after the decimal point in my two numbers. So there's 1 in the first number and then 2 in the second one. So then I move the decimal point from the very right to the left 3 times so that I would get 0.366 instead of 366. And for division, so when you're doing long division, you multiply both the divisor and the dividend. So the divisor is the number you're dividing by, and the dividend is the number you're dividing into by 10 until the divisor is a whole number. So this is when it's a decimal, like the divisor is a decimal. So yeah, and then you just move the decimal point up into your answer. So all of this should have been review for you guys, the fractions and decimals. But if you have any questions, you can ask them now. Okay.
All right, so we're going to briefly cover rounding, which I'm sure all of you know how to do, but this is very important because, questions are going to ask you to round to specific places. And if you don't do that, you're likely going to get it wrong. So if the question says like to the nearest 10th to the nearest hundredths, that means that the lowest value digit in the answer needs to have that place value. So the steps for rounding a number is to first look at the digit after the digit you're going to round to. So if you're rounding to the tenths, you need to look at the ones place. If that digit is 5 or higher, you need to increase the digit before it by 1. And then you basically change get rid of everything after that, or change it to like a 0. If the digit is 4 or less, then you just get rid of the digits after the digit you round to. So that's kind of confusing. Let's give an example. Mindy made 3 purchases for $1.98, $5.04, and $9.89. Yeah. What was her total to the nearest dollar? So go ahead, try to solve this as fast as you can and think about what's the most efficient way to do it. Oh, and here are the answer options. All right, come on, guys, you have 10 seconds. Think about using rounding. Okay. 5, 4, 3, 2, 1. Okay, so the answer is D. But there, and Charles put the equation in the chat, but there is a much faster way to do it than just adding everything. So to save time, we just round. You can see all of those values are conveniently close to being like whole dollars. And we're going to just round all of them to whole dollars because, we need to find her total to the nearest dollar. So 1.98 rounds to 2 because we look at the number, the tenths place, that's a 9, which is greater than 5. So we round that to $2. And the same thing, 5.04 rounds to $5, 9.89 rounds to $10. And then we simply do 2 plus 5 plus 10. And you could solve this problem in just like 10 seconds, like I said. Yeah, it's not that much of a time save, but just to give an example. Nice job, Hannah.
Are repeating decimals like irrational numbers?
We're going to cover like repeating decimal.
Yeah. Repeating decimal. Okay, so we're gonna do repeating decimals now. And typical decimals such as 1.2 and 8.25 are that have a clear end. They're called terminating decimals. to represent to represent the repeating decimal, you're usually going to see this bar above what's being repeated. So like for example, there's you guys see the 0.3 that's being repeated. So that means that it's going to be like 0.3333333 like infinitely. Okay. And so the decimals that go on infinitely, you can always represent them as a fraction. So for example, 0.3 repeated, like going on infinitely, that would be 1/3. And you guys can use your calculators to check this, but that would be 1/3. And but that decimal can be represented as 1/3. A unibrow. Yeah. Okay. You. Okay. So the 3 goes on forever while repeating, meaning 1/3 isn't. Meaning 1/3 in decimal form is a repeating decimal, and you write the repeating decimal again with the little bar on top. Okay. So, one way to tell if a simplified fraction will be terminating or a repeating decimal when converted into decimal form is if the numerator is divisible by 2 or 5. Then it would be a terminating decimal, or that means it has like a clear end. But if the denominator is divisible by any other prime that is not 2 or 5, then it is a repeating decimal. So for example, 1/100 is going to be terminating, which means it ends again, and then 1/15, even though it's divisible by 5, it's also divisible by 3, so it's going to be repeating. And then 7/64 is going to be terminating because it is only divisible by 2's. So let's do a quick example. So which of the following are all repeating decimals? Okay, I see B. That's okay. I see. Someone said B. Someone said D. It's all of the. Select all of the ones that apply. So it's not just going to be a one answer. Okay, so some people are saying that the answers are going to be B and D. And actually, you guys are going to be mistaken. You are okay. Charles got it at the end, but you're going to be missing A. And remember, to make it a repeating decimal, it can be divisible by 2 and 5, but it has to be but it also has to be divisible by another prime. So for example, 115 is divisible by 115 is divisible by another prime, which is 23. Okay, and then B is divisible by 7, which is not which is a prime that is not 2 or 5. And part C, let's see part or option C is divisible by only 5s. Option D is divisible by 13, which is a prime that is not 2 or 5. And part E is divisible by only 2s and 5s. So the only answer options that are repeating decimals are going to be A, B, and D, because those are the only ones that are divisible by primes. Those are the only ones whose denominators are divisible by primes that are. So if it's only divisible by either 5 or 2 and no other prime, it's repeating. No, if it's divisible by either 5 or 2, but no other prime, then it's going to be a terminating decimal. So for C and D are both terminating because they're only divisible by 2 or 5, not by any other primes, like the denominators. But A, B, and D are all divisible by another prime that's not 2 or 5. Okay?
So what is a ratio? If you guys want to put your answer to this question in the chat, I have a feeling that some of you guys might know what it is already. So, okay, so a direct comparison with two things. Yeah. A proportion. So we'll go into more detail later, but a ratio isn't exactly the same thing as a proportion. Yeah, and it's okay if you don't know, because we'll learn it right now. Okay, so a ratio is used to compare the relative quantities of two or more groups or items of data. So it is like a comparison, and the numbers in the ratio do not tell us anything about the actual amount of the quantities. So what that means is, like, if our ratio is 2 to 3, that doesn't mean there's actually 2 things in the first group and 3 things in the second group. That's just their relative, like, that's just their relationship. So it can be written in 3 different ways. So our first one is with this, like, colon, so 4 to 5, like that. And then it can be written like out into words, so 4 to 5, and that's how you read it. And then 4 over 5, so like a fraction. And because we can even write it like fractions, so they're really similar to fractions, you have to write them in simplest form. So if I get a ratio of like 3 to 6, then I have to simplify it to 1 to 2. So our example problem, so if you want to answer this in the chat, that'd be great. So what is the ratio of green letters to red letters in the sentence below? And make sure it's in simplest form. So note that it says letters, not like words. Just a hint. Okay, so I saw a couple of like 5 to 3s, which I'm guessing you thought it was words. And then some 7 to 4s, which is right. And I also saw an answer that said 4 to 7. But that's something like you could easily mess up on. But you have to realize that when you're writing a ratio, this question, it says green letters to red letters. So it has to be green to red, not red to green. So the order matters. So yeah, when you count the letters, you can see that there's 21 green letters and then 12 red ones. So once you simplify, which is also a key step, you get 7 over 4.
Okay, so again, what do you guys know about proportions? Can you give like definitions or examples? Yeah, two sizes compared. All right, this one's probably a little bit more tricky to define than all the other ones. Okay. Yeah, that's definitely an example. So as you can see in the example that Charles gave, like that's something that you could use cross multiplication to solve. And so basically cross multiplication is really big in just solving proportions. But so let's give an actual definition. A proportion is when two ratios are equal. And then this lets you solve for an unknown value in one of the ratios. So for example, to make lemonade, I need 2 lemons to make 500 milliliters of lemonade. How many lemons do I need to make 1,500 milliliters of lemonade? So what equation would you guys set up for this problem? Yep, that's perfect. And then, okay, if you solve that one, you get 6 lemons. So what you can do is you can solve this using cross multiplication. And then you multiply 2 times 1,500 to get you 3,000. And then okay, so 3,000 equals 500 times question mark lemons. And so you know that the amount of lemons must be 6. Or you can think about it as 500 milliliters, but we're multiplying that by 3 times to get 1,500 milliliters. So we also need to multiply the number of lemons by 3 times. Yeah, or you could find how much lemonade 1 makes, but that's a little bit more tedious. Oh, and you can see here. Yeah, this is the multiply by 3 method. Okay, another example. Kelly can read 5 pages of her fiction book or 2 pages of her history book in 7 minutes. If Kelly wants to read 30 pages of each book, for how many minutes in total must she read? So here you're going to require 2 different proportions. All right, so I'll give a little bit of a hint. So let's work out this fiction book one. So she reads 5 pages of her fiction book in 7 minutes. And so we can write 5 over 7. And then, so she wants to read 30 pages of her book. So we have the pages up in the numerator, and we must have the pages also in the numerator over here. And then we want to find how many minutes it takes her to read 30 pages of that fiction book. Then you do something similar for the history textbook. Okay, some people are saying 147 in the chat, and that is the correct answer. So let's set up this ratio for the history textbook. We put the total number of pages in 7 minutes, and then here she also wants to read 30 pages of that, and we need to solve for x over here. Okay, so let me erase all of this because we have prettier examples on the slides. Here are our proportions, and then we solve them. We'll just use the multiplication method. So 5 times 6 equals 30, and we have to do 7 times 6, which equals 42. So it takes her 42 minutes to read 30 pages of her fiction book. And then the same thing where you multiply by 15 here, 105 minutes for her history textbook. So 42 plus 105 equals 147 minutes. And good job, everyone who got that. All right, next example. The top of one tree is 16 feet higher than the top of another tree. The heights of the two trees are in the ratio 3 to 4. In feet, how tall is the taller tree? Okay, so it looks like people are saying B or 64, which is the correct answer. So for an explanation, if the height, here's one method to solve it. It looks like you guys might have used a different method, and that's fine. If we say the height of the shorter tree is h, then the height of the taller one would be h plus 16. And so now we need to set up a proportion with the ratios of the heights and then use cross multiplication to solve. So if we look over here, we can see the proportion that we set up. So h over h plus 16 equals 3 over 4, because that's what it tells us in the problem. And then now we use cross multiplication to solve that. So we do h times 4 equals 3 times the quantity of h plus 16. And then that gives us that equation you can see there. So we use distributive property, 3h plus 48 plus 4h. Like, remember, you guys all know how to solve for a variable. So our final answer is h equals 48. But remember, it's asking us for how tall is the taller tree. So we have to add 16 to that, and our answer is 64. And yeah, Charles, his explanation in the chat is also good.
Yeah, okay. Now we're going to have like a 5-minute break since we've covered most of the content for today's class. And after the 5-minute break, we're going to resume and we're going to just do a lot of problems and make sure that we practice these concepts. Okay? If you have any questions, you can ask now.
Okay, that concludes our break. So I hope you guys are ready to continue.
4. And then right.
Okay, so we're going to do some practice problems. And here's the first one.
Okay, so Arthur wanted to estimate the value of 52.3 divided by 0.11. So he decided to round each of the numbers 52.3 and 0.11 to the nearest whole number before dividing. And Arthur's plan failed badly. So what would have been his estimate if he had rounded each of the numbers to the biggest decimal place? So that is 52.3 to the nearest 10 and 0.11 to the nearest 10th before dividing. So we'll give you a second to get your answer. So make sure you read the question carefully for this one. Okay, so I see a lot of people saying 520, but the actual answer is 500. So this is because you first have to round 52.3 to the nearest 10. So the nearest 10 is going to be the 5 on the very left. So that gives us 50 since 2 is less than 5. And then if you round 0.11 to the nearest 10th, that gives us 0.1. So if we divide 50 by 0.1, then that gives us 500.
All right, problem 2. Jefferson Middle School has the same number of boys and girls. 3/4 of the girls and 2/3 of the boys went on a field trip. What fraction of the students on the field trip were girls? All right, so they seem to be a little bit conflicted. A lot of people are saying D, some people are saying B, some people are saying A, I think. All right, so let's see what the actual answer is. And it is B. So let's go through how the best way to solve this. So we know that the number of boys and girls is the same. And since it's not asking us like how many girls or boys there are, that's the exact number is irrelevant. And we can just deal with fractions and ratios. So our first step should be to find a common denominator for the two fractions, so then we can compare the relative amounts of both. And so the least common multiple of 3 and 4 is 12. So we use that as our common denominator, and then we get 9/12 of the girls and 8/12 of the boys. Since girls and boys have the same number of people at the school, we can just convert that directly to a ratio. So the ratio of girls to boys is 9:8. But now we have to find what fraction of the students on the field trip were girls. So since each unit is like an equivalent amount of people, we can just add 9 plus 8. And then that gives us like the total ratio of the total students. And then the ratio of girls is still 9. So then our answer is 9/17. Does anyone have any questions about this one? Okay, let's continue then.
Okay. There are four more girls than boys in Miss Rob's class of 28 kids. What is the ratio of the number of girls to the number of boys in our class? Okay, I see a few B's. Mostly everyone is saying B. And the answer here is going to be B. Yeah, it's going to be B. So the way that you do this is you find the number of girls and the number of boys, right? And so they said that there are 4 more girls than boys. So you can say that X is the number of girls, and then X plus 4 would be the number of boys. Or the other way around. So X is the number of boys, and then X plus 4 is the number of girls. And then you add X and X plus 4 to get 2X plus 4 equals 28. And then you subtract from 4 on both sides, and then you get 2X is equal to 24. And then you divide by 2 on both sides, you get X is equal to 12. So there are 12 boys, which means that there's 16 girls in the class. And that means the ratio of girls to boys is going to be 16 to 12. And that, when simplified, is 4/3, which is option B. Are there any questions about that, or like how I determined the amount of girls and boys in the class? Because I think I went through that fast. Okay.
Okay, the ratio of chickens to cows to horses on a farm is 6 to 4 to 1. If the total number of legs is 192, how many cows are there? So make sure to read this question carefully, and I'm sure everybody won't have a problem with this, but just for this problem, chickens would have 2 legs and cows and horses would have 4 legs. Okay, so I see a couple of people put 24, and then I also see a 48. So if a couple of, I'll give you guys like one more minute and see if more people would be able to answer. Okay, so I see more 24s now. So that is the correct answer. So there are 24 cows. And this is because, so we first have to rewrite the ratio, which is about like the number of chickens, the number of cows, and the number of horses, to a ratio about the number of legs. So to do this, we have to multiply like the parts of the ratio by the number of legs each animal has. So we would do 6 times 2 since chickens have 2 legs, and then 4 times 4 and 1 times 4 since cows and horses have 4 legs. So that would give us 12 to 16 to 4, or when simplified, 3 to 4 to 1. And if we try to write the ratio of the number of cow legs to the number of total legs, that would be 4 to 8 or 1 to 2. Because if we look in our ratio about the number of legs, we see that it's 3 to 4 to 1. And since the parts are like equal, we can find the total by adding each of the numbers in the ratio to get 8. So half of 192 is 96. So that means out of the 192 legs, 96 of them are cow legs. So after this, we have to make sure to divide by 4 to find the number of cows instead of the number of cow legs. So that's how we get 24 as our answer. Did that make sense to everybody? Okay, I'm guessing it did.
All right, problem 5. The distance between two cities on a map is 15 inches. If the scale is 0.25 inches, is that 0.25 inches equals 3 miles. How many miles apart are these actual cities? Good job. So like all of you are saying, the answer here would be 180 miles. And for an explanation, so the proportion we should set up looks like this. 0.25 inches over 3 miles equals 15 inches over an unknown number of miles. And so here we multiply by 60 on the numerator, so we also have to multiply the denominator by 60. And 3 times 60 equals 180. So the cities are 180 miles apart.
Okay, so are there any questions about anything that we've learned today? Any of the content, ratios, proportions, decimals, fractions, anything? If you have a question, you can like type it privately to one of the teachers and they can answer your question. But if like no one has any questions, then we're going to move on to an activity. Okay, I'm assuming like no questions at all. Are we going to do Kahoot? Not today. I don't think we're going to do a Kahoot today.
It
Maybe.
depends on how fast we finish this. Yeah, but probably not, I'm gonna say. Okay, so this fun activity is not a Kahoot, so we're gonna have to explain this a little bit. So basically, we're gonna be split, you guys are gonna be split into 2 breakout rooms in just a second. So your goal is to solve as many problems as possible within 25 minutes. And there's 10 questions, so you guys will probably solve all of them. But the group with the most correct answers at the end of the 25 minutes gets to win. So you don't really have any like prize, but you just get to say you won. So you have to work together during this. So you're put into breakout rooms to like work as a team. So you could work through them by yourself, and then at the end, when everyone's done, check answers. Or you could go through them one by one together, so you can like discuss each of the questions one by one, or whatever else you guys want. So, and you have 25 minutes for these 10 questions so that you can learn to pace yourself a bit. And some of the extra time is for you guys to discuss. So make sure you don't just solve it and then like have your own answers, then come back to the main room. And so we're gonna put a link to the document in a second. But just to note, these questions are from past AMC8 tests, so they might be a little bit trickier than what we've done so far, but that's why you have a group, and if you can't solve it all, that's also okay. Oh, and after the 25 minutes, you will just like stop the breakout rooms, and one person from both groups can put like all your answers in the chat to one of the teachers. So here is the link for the document. And it's gonna make you make a copy, I think. So Yolanda, if you could like make the breakout rooms, and I guess we'll assign one of us to both rooms so we can like
Should I like stay in this main room, or should I just, is there anything to do?
Huh?
Like,
What?
is it necessary to leave someone in the main room?
Well, I mean, not really, I
I'm
guess.
not sure. I can't assign myself to a breakout room, so I'm not sure if I can even go in there.
Oh, maybe once you make them, you can just go in because you should be able to.
Well, all right, I'm gonna open all the rooms now. Okay, so make sure you guys open that document.
Okay, it shouldn't say you need access, so maybe you should change your account. It should just say make a copy of blah, 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 and then you just, yeah. Okay, so it should say that Yolanda is inviting you to join a room, so please go to them now.
All right, Prisha and Aditya, go ahead and join your rooms, okay? It should show up on your screen as an option.
Hello?
I'm going to assign you to a room, all right?
Oh, yeah, 1 second. I'm already in the Zoom meeting. I'm just like joining from my iPad. Can you send me the link one more time for the document? Because it says I need access, so I joined from my iPad.
All right. I don't know how to not send you back to, okay. I'll just, let's see.
Can you just put the thing back in the chat?
Yeah, I'm gonna go find it. Oops.
So usually when we work through this, like when I was on the math counts team at Mizik, the way that people would have some people go like together, they go from like 1 to 5.
Okay, there we go.
Thank you.
10 to 5. Yeah, no problem.
So like do that. I could try to
All right, welcome back. I hope you guys had fun doing that.
Okay, so we'll give we'll wait like
20 more
a
seconds.
bit more for everyone to come back.
Well, wait, how will the answering system work?
So once everyone comes back, one person from each team, you guys can like direct message me, I guess, with your answers. Just write write them in order, or write like 1 is something, 2 is something, like that. Okay, so Charles will do it for room 1.
Okay, so someone from room 2, private message Kayang with like all of your answers labeled.
Wait, who do I do I private message Caillou?
Yeah, that's
Oh
me.
yeah, okay.
Okay, and for room 2, Aishwarya is gonna do it. If you could send it in one message, because you guys are like overlapping.
All right, so after we finish checking the answers and see how many points you guys got, we're gonna go over and explain all the questions.
Yeah. They're still typing everything, so we'll give them like a couple more minutes. So I'm just waiting for room 2 now.
Yeah, I'm typing.
Yeah, that's fine. Okay, I'm just gonna check one more time that I did count this right. Okay, so we do not have a tie, and we do have a team that won. So one of the teams got one wrong, and then the other one got all of it correct. So both of you guys did very well. So
Wow,
first of all,
that's
good job
good.
for working together. I know at least my team did a really good job collaborating.
Very intense.
Yeah.
So our winner is, so just know that room 1 is the one Charles is in, and room 2 is the one, I don't know if I'm saying your name right, but Aishwarya, was it?
Yeah, that's right.
Okay, so the winner is, drum roll please, room 2. Good job, guys. We got all of it right. All of you guys did really well.
Wow, this is so sad.
Yeah, think about this. This is like all meant for like 8th graders or just middle schoolers, and a lot of you guys haven't even.
Which one did room
Yeah,
one
which one did we
miss?
get wrong?
So it was actually number 9.
9.
I think you guys made like a silly mistake.
Oh wait, we didn't add
Did you
we
say
didn't add
E?
the waters. We were supposed to do like 440 over 1,200.
Did room 1 do E?
Oh, wait, hold
For
on.
9?
Yeah, we're supposed to do.
Room 1 put D instead of C.
Oh, we had a whole like conversation about 9 in our room.
Okay, wait, hold on. I'm gonna redo this, Rebecca.
Okay, so we're gonna explain it anyways right now. So, oh,
Yeah.
and if any of you guys were like stuck on or had to spend more time on any of these questions, we'll go over them to see if there's like a better way, or if you guys did it correctly.
All right.
So we're supposed to go over 3.
So I think 1 and 2 are pretty easy, right? So we can skip those.
Oh, I see what I see what I
I
we
see
did
what we did
wrong.
wrong.
Yeah, I think we did 440, right? What?
Yeah, no, we did 440. 440 was right. We didn't
No,
add.
no. It
440 and
was
700.
640. It was 640.
No, it was 440 for C. You know what? Just talk in the chat.
Okay.
Okay, so starting with 3, there's actually a sort of simple trick. You can just like find the common denominator, but there's a pretty simple trick to compare like fractions and see which one's bigger. Although you have to be careful not to confuse this with like cross multiplication. So what you do is you do 5 times 21, which would be 105, and then you just write that up there on this side. We're going to divide it in 2, and then 19 times 7, which would be 133. And then whichever one is bigger, then that's the side that's like bigger, if that makes sense. And so just make sure you write it on the right side. And so then you can see that 7 over 21 is bigger than 5 over 19. And so we can also do the same thing for 9 over 23. Let's just compare that to 7 over 21. Oops, what am I writing? Okay, so then 9 times 21 equals 189. And then 7 times 23 equals 161. So you can see that obviously this one right here would be bigger. And so then the order we have is like 5 over 19 is less than 7 over 21, which is less than 19 over 23. And All of you got that. So I don't know if you guys used like the common denominator method, but this is probably faster. Kayam, do you want to go over 4?
Sure, I guess. Okay, well, can I have like the pen?
You have it now.
Oh, okay. So it says a number of students from Fibonacci Middle School are taking part in a community service project. The ratio of 8th graders to 6th graders is 5:2, and the ratio of 8th graders to 7th graders is 8:5. So what is the smallest number of students that could be participating in the project? Okay, so first thing to note is that we can't have like a fraction of a person. So each person has to be like a whole person. So the number of 8th graders, 7th graders, and 6th graders all have to be integers. And so first we see that 8th graders to 6th graders is 5:3. So 8th to 6th is 5:3. And then it tells us that 8th graders to 7th graders is, is 8:5. So we can see that the grade that's in both of these ratios is 8th grade. So you can see it up here. And if we want to be able to like compare all 3 of these grades with each other, then we would have to make like these two, find the LCM of these two. And that would give us like the actual quantities of all of these grades, because we're trying to find the smallest number of students that could be participating. So that's why we would find the LCM between 5 and 8 to find the values of the number of students for each of the grades. So the LCM of 5 and 8 is 40. So then that means that this ratio here would turn into 40 to 24. And then this one on the right will turn into 40 to 25. So now we know that the smallest number of students per each grade are in these ratios. So we know there's 40 8th graders at least, and then 25 7th graders, and then 24 6th graders. So once we add all of that, we get our answer. Oops, that's a 4. So which would be 89, which is E. And all of you guys got that, so good job.
Okay. Gopal, do you want to explain 5?
Yeah, sure.
Okay. Do you want me to
So,
give you access to so you can write on the screen?
okay.
Okay, it should work now.
What? Oh. Wait, how do I color? Okay, I got it. All right. A recipe that makes 5 servings of hot chocolate requires 2 squares of chocolate, 1/4 cup of sugar, 1 cup of water, and 4 cups of milk. Jordan has 5 squares of chocolate, 2 cups of sugar, lots of water, and 7 cups of milk. If he maintains the same ratio of ingredients, what is the greatest number of servings of hot chocolate he can make? So, how do you guys think we should start this question?
You should look into all the like he has 5 squares of chocolate, 2 cups of sugar, 7 cups of milk, and like infinite water. So you should, since she needs 4 cups of milk and has 7 cups, 4 cups to make 5 servings, and then C has 7 cups of milk, then he should do like 7/4 times 5.
Okay. What I'm saying is that the smallest limitation is the cups of milk. You don't have that many cups of milk. Therefore, we have to use all of the milk.
Right. So the way I'd look at this is right here, we look at our smallest limitation, right? So recipe, let me reread the question. Okay, right. So our smallest limitation is going to be our cups of milk. So basically, the maximum or like the maximum amount of things that he can, or maximum amount of servings of hot chocolate he can make is going to be limited by the cups of milk, because we don't have that many cups of milk to keep it in the same ratio, to keep the hot chocolate in the same ratio, right? So it's going to be 7/4. So the maximum amount of hot chocolate servings that we can make is going to be 7/4 times 5, and that's going to be 35/4, and that's just that's going to be 8 3/4, I think, which is D. Are there any questions about that? Okay, I guess not.
Okay, number 6 is pretty quick and simple. So you can just solve this really fast using cross multiplication. So yeah, 3 times 45 would get you 135, and then 135 equals 5m. So 135 divided by 5, m equals 29. That looks horrible. 29. And then you just do the same thing for these other two equations. So 29.
Oh, wait. What? M equals 27?
Oh, right. Sorry about that. 27. Yeah. You're right. Okay, so 27. And then basically now the equation is 27n equals 60 times 45. So that would be 2,700. And then so obviously n would equal 100. And then you find m plus n to be 100 plus 27, which would be e. Okay, so good job, guys. And then now on to 7, which I think was probably one of the trickier ones.
Yeah. So 7, at least my group, we had to discuss this. Well, they had to discuss it. But so if you first look at this pattern might not be very obvious, but we can actually see. So you see that the numerator is always 1 bigger than the denominator, and they're all increasing by 1 until the numerator becomes 2006 and the denominator is 2005. So when you multiply fractions, so if we just look at these two, if I'm trying to multiply these two, I'm probably gonna cross out this 3 and this 3, because that's just like an easy way to multiply instead of having to multiply 3 times 4 and then 2 times 3 and having to cross it out at the end. So using this crossing out method, we can actually cross out all these numbers. So if we then look at these two, we can cross out these 4s. And then there would be 6/5 here, which would let us cross out the 5s. So all of these numbers would keep on crossing out with each other until we get to the very, very end. So we would have 2005 over 2004. Then we would have 2000 6 over 2005 as our last number. So these two would cross out, and this would have already been crossed out. So the only numbers that do not cross out are this 2006 at the very end and this 2 from the very beginning. So once all of these other numbers cross out, we would have 2006 over 2. So that would give us 1003, which is C. Yeah, so that might have been hard to see, but once you realize, you can just cross out all of these. So good job if you found that pattern.
All right, go Paul, if you want to do 8.
Okay. On a map, a 12 centimeter length represents 72 kilometers. How many kilometers does a 17 centimeter length represent? And this one, you just, again, you use the ratio, right? So 12 centimeters is going to represent 72 kilometers. And so the fraction 12 over 72 is going to be equal to 17 over x. And then you can cross multiply here and you get 12 times x is equal to 72 times 17. And then you divide on both sides by 12, which gives you 6 times 7, which is 102.
Well, isn't there like an easier way to solve this since 12 goes into 72 6 times?
You
so
could just do
it's-
17 twelfths times 72, and that would give you 102. Usually that's what I do. When I just look at the question, I'm able to tell, oh, it's just 17 twelfths divided times 72. But yeah. What is your easier way? You can go through that.
Oh, well,
You could
the
see-
easier way is just 72 divided by 12 is 6, and then 6 times 17 is 102, because each centimeter would
Yeah.
equal 6 kilometers.
Yeah, when I was explaining the question, I wanted everyone to understand how we used ratios to solve that because again, that's
Oh,
what
okay.
Today's about. I wanted them to understand how we used ratios in proportions. But yeah, your way works as well.
Okay, so number 9. This one is pretty simple. So 2 600 milliliter pitchers contain orange juice. One pitcher is 1/3 full and the other is 2/5 full. So we can just find out exactly how many milliliters are orange juice. The first one is 1/3 times 600, which is 200 milliliters. And the second pitcher is 2/5 times 600. So that would be 240 milliliters. And then they're both poured into one large container. So that large container would contain like 1,200 milliliters because it's combining both of these pitchers. And then you would just add these up to find how much orange juice is in there. So 440. And then you just simplify that and you get an answer of C, I believe. That one is pretty straightforward.
Okay, so our last question was this. So in a far-off land, 3 fish can be traded for 2 loaves of bread, and a loaf of bread can be traded for 4 bags of rice. How many bags of rice is 1 fish worth? So first we can set up ratios. So 3 fish can be traded for 2 loaves of bread, and 1 loaf of bread can be traded for 4 bags of rice. So how many bags of rice is 1 fish worth? So we have to compare rice with fish. And the thing that's in common with both of these ratios is the bread. So if we turn this ratio into one that has 2 breads, then we can compare the fish and the rice. So if we just multiply the top and bottom by 2, then we can get 2b to 8 rice. So that means that 3 fish is equal to 8 bags of rice. So, and then 3 to 8, and it's asking how many bags of rice is 1 fish worth. So if we just divide 8 by 3 to find only 1 bag, and then our answers are in mixed number form. So then that'd be 2 and 2/3. So our answer would be D. And that is our last question.
So again, both teams, you guys did a really good job. I'm
Yeah,
proud of that.
great job for working together.
Yeah. Okay, so let's see.
So if you guys have any questions about anything we've done today, then you can ask now. No? Okay, then we can move on.
So are you enjoy your vacation? Are you gonna attend class on vacation?
Wow.
That's dedication right there.
Yeah. Okay, well, I can go over the homework. So today is obviously Friday. So we won't have another class tomorrow, and this is actually our last class for pre-algebra. So the answers to the homework will be sent to your parents, and you should do the problems and then check your answers over the weekend. So we'll have the answer key. We'll give it to you after this class is over. And next week's join link, so you will go to a different class, not pre-algebra. So whatever you chose or whatever you got for your second week, you will attend that class instead now. So you'll have a new link posted on Sunday on Google Classroom. And if by chance you forgot which class you're going to, you can just check Google Classroom and it will tell you which class you'll be going to. So yeah, that's it for pre-algebra. Hope you enjoyed and you are free to go. I think I'm
Bye.
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 And everyone.
Bye.
Bye.
Bye. Thank you.
Mhm.
Bye.